to discuss one sequential circuit and one combinational circuit, so that we can understand what's the difference between these two circuits. So I have told that about the combinational circuit, that where the output is not dependent on the previous step or something like that. So firstly, we will design a basic multiplexer. Okay, multiplexer is basically a combinational circuit, and in a multiplexer we have different input lines. Okay, and depending on the select line, the output is being selected. That means in case of multiplexer, there will be multiple input lines. So suppose this is a block of a multiplexer. We'll design the internal circuitry. Okay. So this is the input side and this is the output side. So let's see that here in the input side there are 4 lines, and in the output side there are 1 line. That means if it's a multiplexer, we can represent it in this like this way, that marks with the multiplexer, and it has 4 input lines and 1 output line. So it's a 4:1 multiplexer. Okay. Yeah. Sorry. So this is a 4:1 multiplexer. Okay. So from this diagram, you got to know that there are multiple inputs are there and a single output line is there, and there will be some select line. Okay, which helps you to select the output. That means if we can draw a diagram like this way, that this is an indicator, there is something an indicator, okay, which indicates which input will be selected, and there will be select line like you can say S0, S1. These are the select lines, and depending on the select line, the input will be selected. Okay, like say suppose the select line represents binary form like this way, S0 and S1. So suppose when both S0 and S1 are 0, 0, then the first input line, that you can say it as I0, is selected. Okay, when both the select line is 0, 0, then the input I0 is being selected. Okay, then you can have another combination like 0, 1. When the 0, 1 is appeared, like when S1 is 0 and S0 is 1, then the select line S1 will be selected. S1, I1 will be selected. Okay. In the same way, when it is 1, 0, when it is 1, 0, this input is selected, which is I2. In the same way, when 1, 1, this select line is selected. Input line is selected. Okay. So we can see that multiplexer can select a particular input line for a particular time depending on the select line. Okay. And we can calculate the select line in this way, that what will be the number of this select line. Here the select line is 2. Why it is 2? Because the number of input line is 4. That means the number of input line is 4. So we can write it as 2 square. So this square represents the number of select line. Okay. The square represents the number of select line. Okay. So we have seen that. So we have seen that in multiplexer we have defined input lines like 2 or 4 or 8. This number of select lines can be there, maybe 16. Okay, but the output line will be single. Okay. Now we will design a very basic multiplexer, which is 2:1, and I will try to find out the internal circuitry. What will be the digital circuit for that particular multiplexer? So if you take a multiplexer which has 2 input lines and one output line. Okay, always there will be one output line. And as the input line is 2, so it's a 2:1 multiplexer. It's a 2:1 marks. Okay, and as the input line is, the number of input line is 2, so there the number of select line will be the number of input is 2, so the number of select line will be 1, 2 to the power 1. That means the select line will be 1. There will be one select line. Okay, and there will be an enable line which we can, this is select line, this is input I0, this is input I1, this is output Y, and this is enable line. Enable line is to enable the circuit. That means when it is on or when it is 1, the circuit is on, that means circuit will operate, and when it is 0, the circuit will not operate. Okay, so this is the basic block diagram of a 2:1 multiplexer, and now we will design the internal circuitry, and for that we need to take the same type of approach, that we need to draw the, we need to write the truth table first. Okay, we need to find the truth table for this circuit, and here we can write the inputs may be E, like enable, select line S, and output Y. Okay, this is the truth table for the multiplexer. And here, when the enable line is 0, whatever will be the select line, the output will be 0. Okay, when the enable line is 1, okay, again you can take the enable line is 0, but for this case the select line is 1, but there will be no output. The output will be 0 because the enable line is 0. Okay, that's why the output is 0, because the device is switched off now. And then we can have the enable line is 1 and select line is 0. So when enable line is 1, enable is 1, that means that now the circuit is on, and select line is 0. So this input will be selected. First input will be selected. Now we can say the output will be same as I0, because now it is selecting the I0, so this I0 will appear over the output. So you can write when the enable line is 0 and select enable line is 1 and select line is 0, then number 1 input, that is I0, is selected. And when the input enable line is 1 and select line is 1, that means this is 1, this is also 1. So in this case, this input will be selected. So for this case, it will be I1. Okay. For this case, it will be I1. So now from here we can get the equation for this truth table. This is the truth table. From this truth table, we need to find out the equation, and here we can write the equation. That is y will be equal to this y output. So what I have told, that we need to consider when the output is high. Okay, that means for this case output is low, for this case output is low, for this case the output is high. So we need to consider this output, and here I0, that is E is 1, S is 0. E is 1, S is 0, that means S bar into I, the output. Or again, E is 1, S is also 1, I1. Okay. Now from this equation you can take common of E, and if you take common E, it is S bar I0 plus E, then S I1. So we find this equation. Okay. Now we will design the circuit with this equation. Okay. So to draw this circuit, we will have I0, I1. Okay, so you can take the input like this way. I0 and I1 with select line S. Okay, now I am designing the internal circuit for this block. Okay. So S bar, so if you take a NOT gate, we are implementing this equation. So S bar, that means we'll take a NOT gate. Now here S bar, and this is I0, so I0 will be here, and this is an AND gate. Okay. And then again we have S I1. So S I1. And we have a and the OR operation. So we take it OR. And this is how we can get the output Y. So this will be the internal circuit for this block. Okay. And please remember the steps that how we can find out the circuit. Now enable line is there. We have not considered the enable line because we know that it's like a switch. The enable line is like a switch. When it is on, that means when it is 1, the circuit is operating, and when it is 0, the circuit is not operating. Okay. Okay. So this is a basic 2:1 multiplexer. In the same way, we can design 4:1 multiplexer, 8:1 multiplexer, or 16:1 multiplexer, and the numbers maybe goes on. Okay. But the main basic concept is same. Okay. We need to first find out the number of select line, and the select it will be dependent on the power of 2. And after selecting the select line, we can build the truth table. And after building the truth table, we can find the equation. And after finding the equation, we can design the whole circuit. Okay. So this is a kind of combinational circuit. This is a kind of combinational circuit. Okay. And we have another type of circuit which is called sequential circuit. Just copy this one. Then we'll discuss about the sequential circuit. Can I erase it? Okay. There are different types of combinational circuits are there. Okay. This is one of them. And now in sequential circuit, we will discuss about the latches. Okay. We will discuss about the latch first. Because sequential circuit is widely used in memory area. Okay. The memory which you have in your mobile or laptop. These are the basically built with this kind of sequential. Okay, we'll discuss about the latch now, and this is the basic building block of a memory area. You heard about the RAM, ROM. That my mobile has a 8 GB RAM. Okay, specified on your specification on mobile, but these RAMs are built with this basic sequential circuit, this latch or flip flops. It's a basic building block. So we will learn about how we can store a data, how we store a data electronically. So to design it, the latch can be designed in two ways, either with the help of NAND gate or NOR gate. Okay, both the gates can be used to design the flip flops or latch. We'll discuss one type of, let's say suppose we are taking a NOR. This is a NOR gate, okay, and we are designing a NOR latch. This is the circuit diagram for a latch. So here, this input is called as, there are two inputs are there. There are two inputs are there, and two outputs are there. Okay, these two inputs are called set and reset. Like this one is set, and this one is reset. Okay, why it's the set and the reset is needed? Because we need to flip the value of the stored element. Okay, some value you have stored, and now you want to store another value, so you need to reset the device. Sometimes it may be there in your mobile system also. You need to reset your mobile, or you need to reset your laptop. Okay, that means it will erase the previous data, and furthermore it will store the new data. Okay, so there are two types of input. One is set, one is reset. And the output is like Q and Q bar, or Q bar. Okay, that means whatever the output will appear over here, it will be opposite on this output. There are two outputs are there. One is Q and Q bar. That means when it is 0, it is 1. When it is 1, it is 0. Okay. And now, to understand how it works, to understand the working principle of this device, we need to understand the truth table for the NOR gate, and it can be written as if we draw the write down the truth table for NOR gate, the inputs are like AB, and output is Y. AB and output is Y. So the combinations may be 0 0 0 1 1 0 1 1, and in case of NOR gate, when both the inputs are 0, the output will be 1. It will be the opposite of OR gate. Whatever we have seen in case of OR gate, it will be the just opposite of that OR gate. So all the other output will be 0. Okay, so this is the truth table for NOR gate. Okay, now with considering this truth table, we'll find out how this circuit will work. And in this truth table, you can see that when any one input is high, the output is 0. You can see this special feature in this truth table, that when any one of the input is high, the output is 0. This concept will be needed furthermore. So take any cases like First, say suppose in case 1, we have given S equal to 0 and R equal to 1. Now, in any case, we have given S equal to 0 and R equal to 1. Now, what will happen? So, S equal to 0 and R equal to 1. And with the help of this truth table, you got to know that when any input is 1 or any input is high, the output is low. So here you can see this input is high and this is NOR gate. So the output will be low. That means it will be 0. 1, it will be 0. So when it is 0, you can see this is connected with the input of this stage. So this 0 will appear over here. This 0 will appear over here in this way. And now it is 0, 0. Now it is 0, 0. So when it is 0, 0, it will be 1. That means for this output, it will be 1. Okay, now you can see when it is 0, it is 1. Okay. Now see, let me write down the output when Q is equal to 0 and Q bar is equal to 1. So now, now we'll reset the value. That means we'll change the input value. Okay. Now we'll change the input value. And you will see that the output will be the same. That means the output will be stored. Okay. When you are storing some data or images in your mobile, then you suppose you switch off or you are not using your mobile, and then again you just switch on your mobile, you can find the same image. That means the data was stored. The same thing will appear over here. You are switch on, you are switch off your mobile. That means you are giving 0. Okay. With the same concept, let's see here. Now we are giving S is equal to 0, okay, and R is equal to 0. Now for this case, now S is equal to, we are giving S is equal to 0 and R is equal to 0 in the next stage. But these are the values which have already stored on the previous step. So with that, this one will appear over here through this way. When we are giving here 0 with the value of the previous step, which is you can see here, this will appear over here. So this will be 1 now. And when it is 1, you can see any input is 1, that means the output is 0. Whatever the other value. So when it is 1, that means again for this case it will be 0. And it is 0. This 0 will appear over here. The next stage 0, and it is already 0 we are giving. So 0, 0, 0, 0 is 1. So in this state also it will be 1. That means you can see that we have changed the input. Initially the input was 0, 1. Now in this step we are giving 0, 0 for both the cases. But the value of Q is 0 in this step and the value of Q bar is 1. That means you can say you can see in both the stages when it was working and when we have off it, but the value remains stored. Okay, it is just flipping. So that's how a digital system can store a data. This is the basic concept of storing a data in electronic form. Okay. So now I will stop the